Now, in question 11, we're going to analyse some data given to us and graph it. Now, first up, just graphing the data. Pretty quickly, you'll see that it seems to form an exponential decay. It only has to be an approximate scaling, etc. But you see starting off quite high and decaying pretty rapidly, as you'd expect after a gong is hit. 15.6. So the feature there, as per our formula sheet, we've got that exponential decay. So this seems to indicate that R is between 0 and 1. A is going to be 120. Now what I've now got to do is to find the common ratio and see if it confirms the sequence that this generates. So 11A, done. B, what we can say is it shows an R between 1 and 0 exponential decay. For C, A has to be 120. And if I take the ratio of T1, T2 and T1, that's 72 divided by 120, which is 0.6. So therefore, T to the n is equal to 120 times 0.6 to the n minus 1. Now, I could double check that by going T3 divided by T2, but you would find that was 0.6 as well. So therefore, it follows a geometrical sequence. If you want to, you can enter that into your calculator and check the results. Now, in part E, if I want to predict the gong volume after 2 seconds, then what I've got to do in this instance is to enter the 2-second figure is going to be n is equal to 10. So in this case, t at 2 seconds is going to be 10 is equal to 120 times 0.6 the power of 9. And when you process that into your calculator, about 1.2 decibels. A nice little question. I might just quickly show you it on the calculator as well. So you can see when I've entered that as a sequence, you can see the exponential decay or decrease in volume. When it comes to graphing this, there's an element of automatic choosing of points. I could tweak that a little bit if you like, but you can see that the 120 is a little bit out of scope there. The actual numbers are generated like so. A nice little exponential decay in that situation. I might just tweak the graph because it is a little bit weird the way in which I've got it. So I'll just make that 150. I don't mind starting that at -50 because it enables me to see the graph, and I'll put a scale in of 10 and we'll see how that tracks. And you can see that looks a little nicer. And doing the analysis trace, tabbing along 120 through 72, 43, 2 and so on.